Planet Earth has reached a unique historical moment. Humanity evolves, and the scientific and technological progress contribute to change paradigms. As stated by the United Nations since 1987, in order, quotations, to meet the needs of the present without compromising the ability of future generations, close quotations, it is necessary that planners, developers, architects, and engineers constantly reflect on the impact caused by our intervention in the habitat. The increase in world population, the excessive extraction of resources for production from the industrial era, the global exchange, the distribution of consumption of goods and services, all together generate an overall imbalance and jeopardize the continuity of the human species on the planet. It is therefore urgent to transform the current model of development. Designing an eco-sustainable project suggests looking for suitable energy balance with the environment through the rational use of resources which are integrated into the landscape, vegetation, water, and requires optimizing solar radiation and insulation to achieve damping and thermal inertia with better materials. Everything within the parameters of comfort and harmony to decrease the environmental impact. House Opitina project is a work designed, built, and managed by architect Lucia Garzon with a multidisciplinary team. The project was made between mid-2010 and April 2012. At this time, after more than 1 year of use, the house serves as a second home for recreation. The house is located in the rural village Llanitos de Subachoque, in the department of Cundinamarca, on a bleak plateau ecosystem at 2,850 meters above sea level, in the Tablazo Road within coordinates 4 degrees 56 minutes north, 74 degrees 11 minutes west. The village is part of the savanna of Bogota in the Andean zone, 38 kilometers to the west of Colombian capital city, Bogota. Temperatures range between 41 and 64 Fahrenheit degrees, with an average of 53 degrees. The relative humidity moves between 70 and 80% in this high rainfall area. These determinants have affected the occupancy of the house. The project response to the Páramo environment is today under assessment. The building is away from the range of conventional comfort and requires special treatment in the use of materials and construction techniques. The property covers 9.5 acres on an irregular mountain terrain with fruit trees of cold weather. It counts some natural water reservoirs in the midst of a multi-green patches of native forest. 2 houses were built, the main house and the administrative house. There is a total built area of 7,540 square feet. A landscaping intervention with gardens of native and ornamental plants was worked in 2.5 acres, environmentally integrated to the water treatment and irrigation system. The main house of 6,460 square feet consists of a social area on the first floor with an entrance hall, living and dining room, guest bathroom, kitchen, barbecue, service area, service bedroom with bathroom, laundry and pantry. A handicap ramp provides access to the private area of bedrooms, central hall, and 5 bedrooms with a bathroom. plus a large studio. A multipurpose room with bar and wine cellar, a games area, a double garage and a cellar were designed in the basement. The administrative house is a prototype of sustainable social housing of 1,080 square feet, designed under the concept of progressive development and with the perspective of adaptation to urban areas in different climates. It covers a lot of 19 feet wide. The flexible and versatile prototype provides multiple options for 1 or 2 floors. The costs are competitive in the market, and it can likely involve the community in its construction. The small house was designed by prefab modular coordination with prefabricated lumber panels assembled through quincha system, a technique developed and approved in Peru as a conventional construction system since 1987. Quincha system is part of the culture and ancient tradition of woven cane technique and the use of local materials. A single environment comprises the living, dining, and kitchen area. The wall structure includes a timber frame, cans covered with earth and vegetable fibers, and lime for stabilization. Then, there are 3 bedrooms, a bathroom area of separated toilet, wash basin, and shower, a covered clothes patio, an entrance hall with terrace. The design is based on the popular housing types and offers a place of receipt. The roof is made through an experimental technique of wooden structure with a charcoal filling. The charcoal acts as a thermal and acoustic insulation, absorbs moisture, and isolates from the electromagnetism. This material is accessible, affordable, and lightweight that gives the feeling of lightness, a feature of the barrique mix technique. House Supitina was designed as an upscale work within the green architecture that uses techniques of the past with a futuristic vision, that uses materials from the place or within 200 kilometers with a low energy cost during the process of extraction and manufacturing. This experience included several technology innovations that lowered the energy and environmental cost of building and made of this a sustainable home providing the lowest environmental impact by the unconventional materials applied. Among the principles of ecology applied are to decrease the use of natural resources, achieve and rationalize energy efficiency, consider renewable resources in a new perspective, study emissions from materials and building components in the habitat. As a demo project, House Supitina can now be viewed as a living entity interacting with the environment and the site, as well as a laboratory to study and evaluate the quality and pathologies along the time and the post-occupancy. The earth was the selected building material for 3 reasons. First, because it is a material of easy extraction which responds better to bioclimatic factors and to energy savings. A major earth-moving work was done in the site, and soil came out in different colors that were separated from the beginning. It is a low-impact and non-toxic material. Second, because earth as a raw material offers many possibilities of transformation. This proposal applied various construction techniques such as the pressed earth blocks, ramped earth, bahareki, and vaulted roofs of extruded blocks made with a raw soil and terracotta. Third, earth allowed recycling of debris, and the final residues were placed in landfills without causing air pollution. As a natural and recyclable product, lime allows the walls to transpire and purify the air. As lime is aerial, it becomes stiff at absorbing carbon dioxide from the air and provides durability to construction. To the present, the building has not presented any pathology by moisture or fungi, despite being in an area of high risk due to the environmental conditions of humidity and rainfall. Because it is more flexible, lime was the resource of choice, providing excellent quality, plasticity, color, and malleability in the application. The materials of the project with raw earth techniques were applied in 80% of the shell and cover. The use of energy was measured, and savings between 45% and 50% of energy were obtained compared to one construction made with industrial materials and conventional building systems. Regarding shapes, covers with bows was the structural principle. They are self-supporting and ecological. Shape does not struggle with the physics of gravity. Thus, it was applied in all the coverage of the work. Mexican vault, or adobito recostado, was the work technique. For the technology transfer, Mexican bohederos were invited to perform the work, which allowed to evaluate the actual cost of this construction in Colombia and implement new aesthetic and technological possibilities. The cost savings of this type of roof reached 40% faced to conventional roofs. These vaults have no wooden framework. They are just product of the wisdom of the skilled workforce. The economy is evident. However, to reach this quality and organicity in design, training is needed in Colombia to bohederos artisans. The building structure follows the Colombian standards of seismic resistance because the project is located on an area of moderate seismic, the Andes. The main house structure has concrete columns and beams, while the administrative house has a wooden structure. Renewable sources were used, for example the solar panels for heating water, to minimize the building's energy needs. In order to process grey water and sewage, 2 artificial wetlands were built. All systems work biologically, recycle and supply the treated water back to the toilets with full use of entire grey water, purify sewage, and reuse storm water, treating it with slow sand filters. The vehicle access roads were built with the idea of reducing global warming. They were made green roads through technical innovation of the geocells with grass. This is a system that provides stability with a steady surface that allows heavy vehicle transit. The house, up to this day, has responded with high quality. Many technical achievements can be evaluated there, and the earth, featured as the main building material, is providing all of its virtues to the comfort, warmth, and aesthetics. The overall project is a unique demo project, which has resulted so far highly efficiently in terms of energy and aesthetic, with an excellent functionality and harmony, that has understood the forms and meanings of sinuous architecture of the Andean mountains and is approaching the femininity of the shelter. On the terrain and within a certain scale and proportion, House Subitina continues a dialogue with the landscape, with stunning visuals, which are part of a unique and residential architectural experience that from the earth contributes to a dialogue with the new Colombian contemporary ecological architecture, with high standards of comfort and very low energy and environmental impacts.